What if everything, and I mean everything we see around us, from the tiniest subatomic particle to the biggest galaxy cluster, could be described by just one single fundamental object? Well, today we're diving into an incredibly ambitious idea that tries to do just that. It's a unified theory built around something called the A field, and its goal is, well, nothing short of a single mathematical story for all of reality.
You know, the search for a theory of everything has been the holy grail of physics for like a century now. But what if the answer wasn't about bolting a bunch of different theories together? What if, instead, it was all about one fundamental thing, and its different behaviors just look like gravity or particles or forces to us? That's the huge question at the heart of this whole thing.
And the proposed answer to that question is this: the A field. The best way to think of it is as the fundamental stuff of reality. It's not really a particle or a force in the way we usually talk about them. Nope. The theory says it's a fundamental field that exists everywhere, but in a reality that's way, way bigger than the one we actually see.
Okay, so to really wrap our heads around this, we're going to walk through it step by step. First, we'll look at the seven-dimensional stage where this all happens. Then we'll check out the mathematical blueprint it uses, which is just beautiful. After that, we'll see how our familiar universe pops out of all this. And then we get to the really wild part: a totally new origin story for mass, and the specific new particles it predicts we should be out there hunting for right now.
All right, let's kick things off with the first and honestly the biggest idea here. Before we can even really talk about the A field itself, we have to get a handle on the stage where it exists. And according to this theory, that stage is a lot bigger than we ever thought. So here's the deal. The theory says the true playground for physics isn't our familiar four-dimensional space-time. It's actually a seven-dimensional space, a manifold, which is just a fancy mathematical word for a surface. All the complexity of the cosmos, everything the A field does, it's all playing out on this massive 7D stage. In our entire universe, in this picture, it's just a 4D slice of something much, much bigger. Okay, so if reality is a 7D stage, what are the rules of the play? The theory suggests they're written in the language of this absolutely incredible mathematical object called E8. You can think of it as a kind of periodic table for reality itself. And this right here is the magic number, 248. See, E8 is what mathematicians call a symmetry group. Imagine a perfect multidimensional crystal. The structure of that crystal is defined by 248 fundamental parts. Now, in this theory, every single one of those 248 parts corresponds to a fundamental particle or force field. It's the master instruction set for reality. But this is where it gets really interesting. Because here's the core claim of the whole theory. As you can see, less than half of those 248 fields, about 114 of them, can be mapped perfectly onto every single particle and force we already know about. Quarks, electrons, photons, you name it, even gravity. They all have a natural home inside this structure. But that leaves more than half of E8 totally unaccounted for. So this isn't just about explaining our universe. It's predicting a huge, hidden world of new physics just waiting to be discovered. So, big question. If the blueprint is for a 7D reality, why in the world do we only experience 4 dimensions? The theory uses a pretty cool mechanism you might have heard of from string theory. It's called dimensional reduction. Okay, try to picture the 7D space like a giant flat sheet. Now, at every single point on the sheet, 3 of those 7 directions are curled up into a tiny, super intricate little shape, way too small for us to ever see directly. What's left over? The 4 big, stretched-out dimensions that make up the space-time we know and love. But, and this is key, those hidden, curled-up dimensions aren't just gone. As we're about to see, their exact shape holds the answer to one of the deepest mysteries in all of physics. And here it is. This might be the most profound part of this whole idea. This theory proposes that the thing we call mass isn't a fundamental property of particles at all. No. Instead, it's basically an illusion created by the geometry of those tiny hidden dimensions. So the crucial point is this: a particle's mass isn't something it's just born with. It actually emerges from the way two things interact. First, the intricate shape of those hidden dimensions, and second, the rigid mathematical rules from that E8 blueprint. It means if you could somehow change the geometry of that hidden space, you would change the masses of all the particles in our entire universe. Mass is geometry. And look, this isn't just my interpretation. The source material itself is incredibly direct about this.
It says the mass of these force-carrying particles is determined entirely by the geometry of that internal space and the rules of E8. This is a massive shift. It takes mass from being this mysterious number we have to measure, like in the standard model, and turns it into a predictable result of the universe's fundamental shape.
And this is not just some philosophical idea. The theory gives you a precise formula to actually calculate these masses. When you run simulations with a specific geometry for those hidden dimensions, you get a concrete list of numbers, a list of predicted particle masses. Well, technically mass squared, which is just how physicists like to do these things. And look, some particles come out heavy, some come out light, and some, like the photon, come out with zero mass, exactly like they should. The model spits out real, testable numbers.
Which, of course, brings us to the most exciting part for any new idea in physics. Can we actually test it? I mean, if this whole framework is correct, it has to make specific predictions about that hidden world of 134 new particles we can go look for. And guess what? It does.
The theory predicts a whole new zoo of particles. For instance, it points to things called mirror fermions, heavy cousins of the particles we already know, which we could maybe find at colliders like the LHC. It also predicts dark age bosons, which would be carriers of entirely new forces. But then there are the most exotic of them all, something called cosmic knots. So what on earth are these cosmic knots? They aren't made of quarks or electrons or anything we'd call matter. The theory says they are pure, tangled-up configurations of the A field itself, literally held together because they're tied in a knot. They would be unbelievably massive, ancient relics from the dawn of time, and a fantastic candidate for dark matter that isn't made of matter at all, but of pure shape.
And the theory even tells us how we might find them. A cosmic knot, with its complex 7D structure, would subtly warp space-time around it in a weird way. So instead of the simple inverse square law of gravity we all learned in school, you'd see a tiny, tiny correction at very short ranges. This gives us a clear signature, a measurable difference that our most sensitive gravity experiments could actually go out and look for.
So, let's pull all this together. If we step back and look at the big picture, what is the A-field framework really telling us about our reality? The takeaways are pretty profound, right? It suggests one single field in 7 dimensions could be the origin of everything. Mass is no longer fundamental. It's just a side effect of hidden geometry. And crucially, this isn't just philosophy. It's a testable scientific theory with a concrete shopping list of new particles we can actually search for. It paints this incredible picture of our universe as just one small piece of a much grander 248-part reality. In the end, whether this A-field theory turns out to be right or wrong, or just a stepping stone to something even deeper, it forces us to ask a really beautiful question. If the deep structure of reality really is this vast mathematical symphony playing out on a 7D stage, how many of its fundamental notes have we not even heard yet?